Hi, this session is on applications, so applying and using our skills in the real world. All the skills we have learnt about length, perimeter, the metric system, converting units, let's actually use it now into real life applications. Before we start these questions, please make sure you have read through these tips and please write them down. When approaching or attempting these worded problems, make sure you read through the questions carefully and underline any key words. Draw a diagram when you can to see what is happening and to help you understand what the question is asking, and include measurements in your diagram. That's important as well. Convert units when there are different units given, to always check your units. And remember, it's usually best to convert bigger units to smaller units because we know our number will get bigger to try and avoid decimals. But of course, it depends on the question as well. Answer the question with a final sentence that explains what you have found. Okay, it's important to explain what you found and how it relates to the question. Check you have included units in your answer. So your final answer especially must have centimeters or meters, otherwise you won't get full marks. And if a question asks you to use specific units, make sure you convert if you need to, so your final answer is in those units. Okay, let's go shopping. So I went online and went to the Bunnings website and I saw this table that I could use outside. So this table is available at Bunnings. So A asks us, what is the length of the table? And B, what is the width of the table? Now if I have a look at the information provided, this table is called a mimosa, and it's got this, 220. Now that looks like times 90 centimeters. Now it's actually not times in this context. It's actually, that symbol is saying by. So 220 by 90 centimeters. They are, that is a dimension. So these are the dimensions of the rectangular table, the rectangular part, okay? So we can see it's saying that's the length, the longer side, by the width, 90. Okay, so length by width, that's what it's saying. And we have seen that keyword dimension in a previous slide. Dimensions is another word for length, but it actually has more than one length. In this case, the length and the width. Okay, so I have drawn a diagram of the tabletop. It's a rectangular shape. Even though there was a diagram or a picture of the table given to us, I still want to put in my dimensions. Okay, so length by width, and it's a rectangle. So I know this side is also equal to 220 centimeters and this side is 90 centimeters. Sorry, it's a bit crooked now. Okay, so A asks us, okay, what is the length of the table? Well, we know it's 220 centimeters. And then what is the width? Well, the width is 90 centimeters. Okay, and once again, it was length by width. So 220 was the longer side. All right, now C asks us to work out what is the perimeter of the table using the given units. So our units are in centimeters. Okay, so perimeter is equal to, add up all the sides. So I have 220 plus 220 plus 90 plus 90. Now I'm doing this without a calculator, so I will set up my algorithm. Make sure you have lined up the ones and the place value correctly. Alright, so I've got 0 plus 0 plus 0, that's just 0. I've got, well, 9 plus 9 is 18, plus that 4 leaves me with 22, and then 2, 4, 6. So I get my 620. So the perimeter is equal to 620. Don't forget, this is in centimeters. Okay? So the perimeter of this table is 620 centimeters. Now D asks us, what is the perimeter of the table in meters? So they want us to convert the units. So if I convert the units, I don't need to change these ones. I've got the whole perimeter here. So all I need to do for D is convert 620 centimeters into meters. So I want to change 620 centimeters is equal to how many meters? Now we have done many of these questions before. We have used a conversion chart. I might try this one mentally, but if you need to use a conversion chart, you should know how to draw it yourself as well. So I can see that centimeters the unit centimeters is smaller than meters. So my number should be getting smaller, which means I should be dividing by something. Now, what I divide by is, I know that 100 centimeters makes up 1 meter. Okay? So that means I divide by 100. So I'm trying this mentally. You can use your conversion chart. So 620, just put equal signs, divided by 100. So this is where I get my decimal. There it is. And I move it 2 places to the left. And I'm getting smaller. So it's gone from there. So I've got 6.2. Don't have to write the 0 at the end. It's 6.2 meters. So the perimeter in meters is 6.2. Okay, next question. Question 2, it says multiplication on the farm. So we might be using multiplication to help work out this problem. Let's read it. A horse paddock is to be fenced on all sides. So picture a paddock on a farm, like a field, and it has to be fenced off to keep, I guess, the animals in. It is rectangular in shape. So I've highlighted the word rectangular, okay? So straight away I know what shape I'm working with. Now, it has a length of 242 meters. So that's also important. I'll underline that. And a width of 186 meters. If the fencing costs now $25 per meter, find the cost of the fencing required. So the farmer wants to work out, he or she needs to put a fence up around a rectangular paddock. So the perimeter of the paddock, how much will it cost? So the first thing I have done is I've drawn my paddock. It's a rectangular shape and the length is 242 meters, width is 186 meters. Easy. Now, I know my fence needs to go along the border of this paddock, which is my perimeter. So I am just finding the perimeter at this stage. So perimeter is equal to, now I know this side is also 242 meters and this side is 186 meters. So let's work out how many meters of fencing we need. To do that, we work out the perimeter. So 242 plus 242 plus 186 and 186. So we'll do this without a calculator. Okay, so here's my algorithm, making sure all my place value is correct. Yes. So I've got, 6 plus 6 is 12, plus the 2 and 2, so plus 4 is 16. Put the 6 down, we'll add the 1. 8 plus 8 is 16, plus 4 is 20, plus 4 is 24, plus 1 is 25. And then I've got 2, 4, 6, 8. So my perimeter is 856 meters. Okay, so that's how much fencing I will need to go all the way around this paddock. That's the perimeter. Now the question asks us, if we go back, find the cost of the fencing. That's what we want to know. What is the cost going to be? Now we know it costs $25 per meter. Okay, so this is where we have to work out a way to calculate the cost. So if I've got 856 meters and each meter costs $25, the best way to work it out is using multiplication. Okay, so let's set up our algorithm over here. So I've got 856, I'll just fix that up, times $25, because that's per meter. I don't have to put dollar signs in or meters, just write the numbers. Okay, so we know how to multiply using an algorithm. We're going to have to add, because I can see I've got 1s and 10s. So I'll just change my color. Alright, so 5 times 6 is 30. Put the 0 down and we're going to add the 3 later, so plus 3. 5 times 5 is 25, plus the 3 is 28. Put the 8 down, carry the 2. 5 times 8 is 40, plus the 2 is 42. Okay, so now that I've got that, I'm going to my 2, which is in my tens column, so I must add that 0. We can call it the magic 0 before I do anything. And now I start multiplying. 2 times 6 is 12, put the 2 down, and I'll also rub this off because I'm starting again, so I don't get confused. So 2 times 6 is 12, put the 2 down, Oops, sorry about that. Just start it again. So 2 times 6 is 12. Put the 2 down, and we've got to add the 1. First multiply. 2 times 5 is 10, plus 1 is 11, and add the 1 here. 2 times 8 is 16, plus the 1 is 17. And now that I have multiplied all of my digits over here, just add these. So we've got 0, 8 plus 2 is 10, 0 down, we'll add the 1. So 2 plus 2 is 4, 7 plus 4, 11, put the 1 down, add the 1, and 1 plus 1 is 2. Okay, so what is this value? Well, it's the cost of the fence required for our paddock. So let's write our final answer and we'll make sense of this. So I'll just put a comma in, 1, 2, 3, comma. So that's $21,400. So the cost is in dollars. So that's actually it's going to cost us $21,400 to put a fence around that rectangular paddock, which is, I guess, quite expensive, isn't it? Must be a good fence. Now, we have to write our final answer. So to do that, use your final answer, use the keywords in the question. So we can say the cost of fencing will be, and what we found. Okay, there's my sentence. The cost of fencing will be $21,400. Or we can say will cost. Okay. All right, for our next question, question 3, it says using division to build a wall. So we might need to use our skill in division to help us work out this problem. A builder needs to build a wall 4 meters high. If each layer of bricks adds 8 centimeters of height, how many layers will the wall be? So this helps us to work out, I guess, how many bricks we'll need, because how many layers of bricks will we need? So first of all, draw a diagram. Okay, so when drawing a diagram, you don't have to draw things very fancy. Just draw them simple and basic. Otherwise, your diagram can look confusing. So I've just drawn this line, and that is my wall. Okay, nice and simple. And now the length of this wall, so remember we add in lengths or dimensions and widths. The length of the wall is 4 meters. So that's how high that wall is. Okay, so sort of like, I guess, a double-story house. Now, each layer of brick adds 8 centimeters of height. So each layer is 8 centimeters. So we can see that the next thing we might have to do is change our meters into centimeters. So 4 meters is equal to how many centimeters? I'm starting with a bigger unit, so my 4 should get bigger. We can use a conversion chart, but because I know that 100 centimeters makes up 1 meter, well, and I'm getting bigger, I'll just times it by 100. So I get 400 centimeters. Use a conversion chart if you need to, no problem. So it's 4 meters, or we can say 400 centimeters. Okay? Now each layer of brick, so if I do a layer of brick, each layer of brick, so imagine these are my bricks. We can draw the ground. So the ground's just there. It's the first layer. So from there to there, each layer of brick, it says it was 8 centimeters. So 8 centimeters. Okay? So that's what's happening. With each layer of brick, so if I do another layer, that layer, oh sorry. So here's another layer, our second layer. That is also, no, you don't lay bricks like that, but oh well. That is also going to be a layer of 8 centimeters. Okay, so each layer is 8 centimeters. Now, how many of these layers do I need to reach 400 centimeters, to reach 4 meters? Now, we can keep adding layers and add up our 8. So 8 plus 8 is 16, and keep going that way, but that will take us longer. This is where division comes in. All I have to do is get my 400 centimeters, so the same units which we converted, and divide it by 8. And that will tell me exactly how many layers I need. So we know how to divide. We have practiced this. When setting up our algorithm, we know that these two switch places. So 400 goes in here and 8 out there. And now let's start dividing. So 8. So can 8 fit into 4? No. or the other way of doing it, 4 divided by 8. That doesn't work, so we get 0. We haven't used that 4, and it goes on to our next number, and we have 4 and 0 together make 40. So 8 into 40, or 40 divided by 8. So 8 into 40 can go how many times? I know my timetables. 8 times 5 is 40, so 5 times. Now, there are no remainders, but this 0, I can't forget about it, okay? So I have to, if I don't use that 0, make sure you add it up here, okay? Or 0 divided by 8 is just 0. So I don't need this 0 over here, that can disappear. So my answer is 50. Now make sense of this. What does that 50 mean? It's saying we need 50 layers of bricks, so 50 of these, to reach 400 centimeters. Let's write our final sentence. So go back to the question and use keywords from here. So we can say the wall will be 50 layers high. Perfect. There we go. There's my sentence. I've also added this keyword we'll start seeing, therefore. It's a way to I guess start your sentence. Therefore, the wall will be 50 layers high. Now, we don't have to write units here because we're just talking about a layer. Okay? So how many layers do we need? Okay, question 4. This says subtraction comes in handy. So we might need to use our skill in subtracting to help work out this application. Alright, Adrian is driving a truck with a rooftop 3.4 meters above road level. Okay, so that's how high his truck is when it's on the road. When he approaches an overpass bridge which has a clearance of 376 centimeters. Alright, so straight away, first visualize what's happening. Adrian's driving a truck. Okay, that's how high the truck is while it's on the road. He's approaching a bridge, and for him to fit under the bridge, he can't be higher than 376 centimeters. If his truck is higher than that, he's going to smash into the bridge. And we've seen on the news a few times, especially last year, a lot of trucks hitting bridges in Melbourne. Now, will Adrian's truck get under the bridge? If so, how much room does he have to spare? And it says give your answer in centimeters. Alright, so there's a lot of information. We understand what's happening and what the question is asking us. Can this truck fit under the bridge? We have these two measurements, 3.4 meters, 376 centimeters. So straight away I can see I have to change my units as well. So first of all, let's draw a diagram. Okay, so remember when drawing diagrams, they just have to be simple. And you're not being assessed on how artistic you are. So there's my truck. Okay, so I'm drawing a truck. And the main thing is, it also tells us that above road level. So we have to draw a road. That'll help us. So there's my road. Okay, so this truck above road level, so we've got the wheels on the truck. This is what I need here now. The height from road level to the top of the truck, what was it, is 3.4 meters. So 3.4 meters. Add that in there. Alright, so that's has helped me to visualize what's happening. Now this truck is approaching an overpass bridge. So my bridge, I'll just put it maybe over here. And we don't know if the truck is going to fit under this bridge, but let's just make it a little bit higher and hope that it does. Now the height of this bridge is, or not so much the height, sorry, the clearance to pass under this bridge can't be more than 376 centimeters. Alright, so for the truck to pass under this bridge, it's 376 centimeters. Okay, now that we can visualize, that's our road, what's happening. So approaching this bridge, can this truck fit under the bridge? Let's now convert our units. Now I'm going to turn 3.4 meters into centimeters. Remember, bigger unit to a smaller unit becomes bigger. The value becomes bigger. So I want to avoid decimals. So I'll do that. So 3.4 meters is equal to how many centimeters? Okay, we could use a conversion chart, but once again, I know 100 centimeters makes up 1 meter. I'm getting bigger, so times by 100. So 3.4 times by 100, 2 zeros, so I have to move 2 places. I'll add a 0 here, and let's start moving. So 1, 2, my decimal point is now there. So
if you want to do the song 1, 2, 1, 2.
Okay, sorry, that was Alexa. Now, so we've got a new spot, so it's now 340. There's my decimal, it can be invisible. So 3.4 meters is 340 centimeters, and I'll write that on my diagram. Now let's compare. I've got 340 centimeters here. A clearance rate is 376 centimeters. So the truck is smaller or lower than the overpass bridge. So yes, it will be able to fit through. So let's answer the first question. Will Adrian's truck get under the bridge? Yes. Okay, so I've answered the first part of my question. Adrian's truck will fit under the bridge. And now the second part of the question, if so, how much room does he have to spare? And give your answer in centimeters, okay? And I should have pointed that out as well. I converted meters into centimeters because the question actually asked us to do that. All right, so how much room does he have to spare? This is where subtraction comes in handy. Okay, so if the truck's at 340 centimeters, how much space is left over? So that it can fit through, or what it had to spare, sorry. Okay, so to work this out, we are finding the difference. What's the difference between 376 centimeters and 340 centimeters? Now, difference is the space between two numbers. So what's the space between 340 and 376? Yes, you can count from 340 and get to 376. That's finding the difference, but why not just subtract? Subtraction means to find the difference. Okay, so 6 take away 0 is just 6. 7 take away 4 is 3. 3 take away 3 is just 0. Okay, so this is in centimeters, so it's telling us, we don't need that 0 there, he had 36 centimeters to spare. So the next part of our question, or our answer, sorry, Adrian's truck will fit under the bridge, and he has 36 centimeters to spare. We have used keywords from our question. Okay, and question 5, our last question for this session, says let's frame a picture. So a rectangular picture of length 65 centimeters and width 35 centimeters, and we can see it here, is surrounded by a frame. There's our frame that has a width of 5 centimeters. So it's telling us the frame has a width of 5 centimeters. So all the way along here, from there to there, the thickness or the width is 5 centimeters. What is the perimeter of the picture? So that's the first thing we need to work out. Okay, so what is the perimeter of the picture? So I've just drawn the picture here and put in my measurements. So length of 65, width of 35. So add up all of these and that will give us our perimeter. So 65 plus 65 plus 35 plus 35. Maybe we can have a go at trying this, adding it mentally, see how you go. Well, I know that 35 plus 35, this here is 70, because 30 plus 30 is 60, and then 5 and 5 makes 10, so 70, that bit there. Now 65 plus 65, I know 60 plus 60 is 120, plus 5 and plus 5, that is 10, so I have 130 plus 70, okay? And perimeter is equal to 200, and we're working in centimeters. Okay, because 130 plus 70, I can work out that, yep, 200 centimeters. All right, so that's a perimeter of just the picture. So remember, we have just found the perimeter of the picture. Now B asks us, what are the dimensions? So the length and width of the frame. Now remember, this is really important information here. The width or thickness of that frame, in terms of how wide it is 5 centimeters. Okay, that's really important. So I'll draw a diagram. All right, so there's my picture that we had before, and we measured the perimeter. Now I've drawn a frame around it. Okay, now it's not to scale, obviously. Now a frame, we know when we have a picture, the frame is the same length or width all the way through. Okay, we don't have a frame where this side's thicker or wider than the other side, because it won't look right. So the thickness of this frame, or the width, it tells us is 5 centimeters. Okay, so from here to here, it's 5 centimeters. From here to here, it's 5 centimeters, and that's all the way around. So I'll add this 5 centimeters, oops, all the way around. I'll do it at the corners, and you'll see why it's good to do it at the corners. Okay, and one more here. I should have changed my color. So we've got all the way around, it's 5 centimeters, and I've done it at my corners. Okay, so there's my original picture. Frame has gone around it, and the width of the frame all the way along is 5 centimeters. So to work out the length and width of the frame, so from what's the width of the actual frame, what's the length of the frame, if I know the picture from here to here was 65 centimeters, I have to add on 5 centimeters on both sides. So the length is all the way from here to here. There's my frame. So all the way, there it is. So I just rubbed off. I've got 5 plus 65 plus 5. So 5 plus 65 plus 5 will give me the length of my frame, and then here the width, I'll do the same thing. So the width of the frame, we're doing the same thing. So I've got 35 plus the 5 plus the 5. Okay, so this whole line here, you can see, is 5 plus 35 plus 5. So 5 plus 35 plus 5. And that would be the length and width of the actual frame. So this question, yes, it was tricky, but drawing a diagram and adding in all of our measurements has helped us to work it out. So what is 65 plus 5 plus 5, or 65 plus 10? That is 75 centimeters. Our units are all in centimeters. 35 plus 10, so 35 plus 5 is 40, plus 5 is 45. So 45 centimeters. Okay, so length is 75 centimeters and the width is 45 centimeters. So to answer question B, if I go back to question B, what are the dimensions of the frame? So write our sentence, dimensions. So there's my sentence. The dimensions of the frame is a length of 75 centimeters and a width equal to 45 centimeters. If you went 75 by 45 centimeters, that's also correct, because we saw in our first example, the Bunnings example, dimensions can be written like that as well. So either one is correct. And our final question, what is the perimeter of the frame? Now that we know the dimensions, we know the length and width, the frame is still a rectangle. Okay, so just add up all the sides of our rectangle. So let's just clean this up a little bit. So I've got 45 centimeters as my width. Length is 75, so 45 here from there to there as well, and a length of 75 from there to there. Oops, too much. So the edge. So add up all of these sides. So perimeter of the frame will be 75 plus 75 plus 45 plus 45. Add this mentally or with an algorithm, and you should have got 240. Our units are still in centimeters. Okay, and now don't forget to write a final answer as a sentence. So therefore the perimeter of the frame is 240 centimeters. Thank you.